Okay, for those who are joining the live stream, this is a meeting about a collection of different features in Wolfram Language which have been tagged as experimental and which we are trying to polish and move towards being non-experimental. So let's start off with initialization-related functions. These don't look very promising in terms of our desire to de-experimentalize them. Roman, I think these are your functions.
Yes, I mean, last meeting we decided that all the persistence functions should remain experimental. So the initialization builds on top of persistence. So I think we.
How much usage of these things got so far?
Well, persistence has got some usage in terms of using it for caching for some of our features like resource objects or audio.
But what about initialization? So, I mean, for me, if I say, what is initialized? From persistent values.
Yes, I mean, initialize is more or less at the moment an internal function that does the initialization of a certain variable. It will become the entry point into the kernel initialization in the future. So at the moment, the point is you say initial value of some symbol equals something, and then the next time you start the kernel, that symbol will automatically be set to that value. So initialize is still under development.
Okay. But so how does this relate to what we're doing with packlets and packlet loading and so on? Is this related or is this unrelated?
No, I mean, packlet is about loading code, and initialization is about setting symbols at the start of a session.
All right. So what's our plan for getting this out of experimental?
Okay, once we consider the persistence to be stable enough and the initialize without any arguments will work to duplicate the kernel initialization, then one more thing that is needed is the initialization browser, because as soon as we have support persistent values, then we need some easy ways for users to browse these values.
Do we have a modified initialization browser?
I'm working on it, and within the next few weeks, I should be able to present it. And then we see, I mean, the design is not difficult, but it requires some thought about the UX. For example, do we want to put it into the persistence, into the system preferences, or do we want it to keep separate, or things like that?
I suspect it should be in preferences, but the way that preferences works has not been uniformized between the cloud and the desktop.
Well, actually, I've never tried to use the preferences in the cloud, but I mean, you are right. I mean,
well, they don't work the same way. I mean, the preferences in the cloud are much more modern in some ways, but they're not as large and complete as the ones in the desktop.
No, I think we need the persistence, the initialization browsers for both environments in more or less the same way.
I mean, right now, the preferences here are mostly contained here under this, right? These are preferences here. And there's a bunch of preferences, but this is nice and modern, but it's definitely a pale shadow of the preferences that are settable here. Right? This is a big preferences system.
Yes, I mean, are there any attempts to unify the two?
There haven't been, but there probably should be, and that probably should be part of the. I mean, it probably should have a custom meeting specifically about this. I mean, you know, I don't even know, you know, some of this stuff like maximum output size before truncation. I mean, that's something that probably could be settable in the cloud, although the parameters are just completely different because it has to do with, you know, browser performance and networks and things like this.
Yes, and certainly parallel would, I mean, it's the first time I think about it, but certainly this panel would warrant its equivalent for the cloud parallelism, for the private cloud.
Fine. Well, I mean, I think fundamentally what we want to do, I mean, like this is completely different story, right? I mean, that's a completely different story for the cloud. So I think what we need to do, and Raj, if you're covering this, then you know, we'll need a meeting with the cloud.
And Matt. Yeah, you did actually request this last time, so I do have.
Well, I'm good. I'm so deterministic. If you feed me the same input, I'll give the same output.
Right. So yes, we will have a meeting to discuss how to sync preferences between cloud and
okay, but okay, fine. But sync as in the design and so on, right?
Correct.
Okay.
Or unify.
Yeah, right. So that's it. Is that it for initialization? We're not de-experimentalizing at this time.
Yeah, I agree fully, because persistence isn't.
Okay. All right. So let's see. Do we have Konstantin here?
No.
Who's representing this?
No, we do not.
So who is representing this section?
I don't know. I will
So
check
why is
with
it
him.
here?
I don't know
Why
why
is
he
it
didn't join.
Okay.
Perhaps skip over. I'll try to find him.
He's away to the end of the month, isn't he?
I have no idea. But who is supposed to be representing this section?
Konstantin is, and he hasn't joined yet. So can you switch to the next
He's
one?
not here. So whatever. Okay. Look, this stuff needs to be de-experimentalized, but it needs to be checked. And there are a bunch of people who are involved in these things. For example, what on earth is this? Who's writing this here? What are you talking about? Who
That
wrote
was
this
Konstantin.
text?
That was
So he
Konstantin.
doesn't know what he's talking about. Who is Konstantin's manager?
I would think that would be Tom.
Tom.
Okay. Well, you guys need to get your act together on this, and let's have a meeting about it. But I think we need to de-experimentalize all these things. I can't see any reason they should stay experimental. Okay. Okay, let's move to a totally different topic, which can involve a different set of people here. I assume we have Jonathan and Jose here.
Yep. Hi.
Hi. Okay, so the folks who were involved in the initialization and scheduled tasks, except there was nobody involved with scheduled tasks. So the person not involved with scheduled tasks can drop. But Roman, if you don't need to stick around, I think, for this.
Okay, goodbye. Good night. Thank you.
See you. Bye.
Bye.
Okay, find equational proof.
Yes, so our recommendation is that this should still be experimental because it's a very recent function and it's changing.
What aspect of it is changing?
Yes, so first, it's being used now by the future synthetic proof geometry group. So they will be using it. And then we have...
What aspect of it?
Well, the idea of proof object. So they want to return their results also as proof objects.
Uh-huh.
And then Jonathan can explain better. We are now adding counterexamples because Wallmeister can also produce counterexamples.
Oh, that's nice.
Yeah,
that's very cool.
Yes.
And so how is that going to be returned? I mean, is that really the same function? Find equational proof. It's like, oops, there isn't a proof, but here's a counterexample.
Right, that's kind of the idea. Yeah, that it'll either return a proof object or a counterexample object, whichever it can find first.
Oh, that's interesting.
And so I can, if you want, I can show you the kind of prototype of the counterexample object.
Let's see it. I had no idea this was coming. This is cool. Okay.
Yeah, I haven't worked on this for about a month or so, but yeah, here we go. So if we have, so if you, at the moment, if you have a theorem and or if you have a statement and it's just obviously false, it will return a failure object.
Mm-hmm.
But if it's something that is false, but it can't be easily reduced to false, it will just hang. So here I'm trying to prove that X times the identity is the identity within the axioms of group theory, which is obviously wrong. But I've added this thing called find equation of counterexample, which if you now run it on that will return this thing, which encodes the counterexample like this. And so what it's doing is it's assigning values to the operator. So here we have just a multiplication operator, and it's assigning values to this multiplication operator.
Like a matrix type. I mean, that's like a multiplication table for that operator.
That's precisely it. And actually, all it's doing internally is just enumerating possible multiplication tables until it finds a counterexample. It's not doing anything very, very sophisticated. And so so it's encoded like that, and then as a sort of parallel to the proof function that's in.
So wait a minute. So that functionality about essentially enumerating models is an alternative to the whole, you could find a proof by enumerating all possible models and showing that they all work.
Right, except that in this instance, this is not a finite. There is no finite set of models that you could just enumerate.
I see. But so in your counterexample finder, is there some way of eventually enumerating in principle after an infinite time, sort of spiraling out into the space of all possible counterexamples until you eventually find one, or what?
Assuming that the statement is decidable, then yes.
Then your procedure can eventually find successively larger counterexamples.
Yes, yeah, because all that it's doing is whether it's
just find models of a certain size and it's got a certain set of elements, discrete set of elements, and it's simply writing down multiplication tables of progressively greater size. Is that correct?
Precisely, yeah. So with this binary operator here, it starts with just a trivial model, then a 2x2 table, then a 3x3, and so on. And in this case, it just found one after enumerating a 2x2 table, because this is quite a simple counterexample. And it turns out that in practical cases, at least of the ones that I've tried, this is efficient enough to find a counterexample pretty much instantly. And I was going to say that in sort of parallel to the proof function that comes as part of the proof object, you can request a sort of falsification function where it actually it hard codes this operator and hard codes the identity element and so on, so that if you run it, it evaluates to false.
Funky. By the way, if you want to find ones that are not so easy to find, if you retrace that logic axiom derivation, that thing, there were plenty there where it was non-trivial to find a counterexample. In other words, there were almost Boolean algebra axiom systems that missed by a quite large counterexample.
Okay, are those available in NKS?
They should be. I mean, actually, I'm about to write a blog post about this stuff, which will feature a bunch of stuff about find equational proof. And I, even over this coming weekend, I might try to write it. If I do that, I will be kind of generating a slightly cleaner version of those old model enumeration things.
Okay, cool.
I think when I did them for the NKS book 20 years ago, I'm pretty sure I wrote C code to do that stuff.
Right.
I'm pretty sure that was all a bunch of highly optimized bit twiddling code, because it was in fact fairly, you had to go a fairly long distance to find counterexamples there. Now, arguably, we could actually use the very same code because it was doing the very same thing. I mean, it was just enumerating possible, things of certain sizes, and I just don't know. Hopefully, with our compiler, this will be something that will be pretty efficient to do.
Would it be sufficiently general that it could work with any equational system, or is it?
I think so. I think it was. I mean, I think it was just. I don't really know what it. Oh no! Wait a minute. It's coming back to me now. It's coming back to me. What I actually did was, I actually machine generated C source code, compiled it, and ran it. So in other words, given the which is what we could now do with the compiler, basically, except going to LLVM rather than C. So, in fact, this would be an interesting exercise for the compiler, I would think. Quite an interesting exercise and comparatively easy, actually. Now, in terms of design, I am not at all convinced that find equational proof should actually return counterexample objects. I think it is. I think it would be better to just say, failure, there isn't a proof. And then separately to have something which is more of a, some kind of model exploring function that would be more in the nature of, with the counterexample, why does it need? So it has the G and the env. I mean, I would have thought that what it should do, I see. Those are multiplication tables in the same sense that Boolean table is a multiplication table derived from Boolean function.
Yes.
And what is our way of representing? How do we go from a multiplication table? So we don't have a good way. I see. In a sense, your way of doing it is if the elements are labeled by successive integers, then it is simply part extraction to, index into the multiplication table.
Yeah, exactly. So it's just a pure function. It's representing the operator as a pure function that's based on part extraction. And yeah, the fact that they're integers just makes it convenient, but these are just arbitrary objects.
Right. Well, the more general case would be a nested association that you could use to have, where then you could have arbitrary objects indexing into it for the multiplication table.
Okay.
Right. I mean, because all you do is, instead of, I mean, I'm not sure whether that's desirable or not, but okay. Well, this is very interesting. Fine. Well, I'm convinced that we should leave it as experimental for now, although I feel like, oh boy, I think this needs a different function. I think this model exploration thing is a different function. And I don't know exactly.
I mean, right now it is, but that, yeah, for the moment, that was just a convenience.
Right. But I feel like what it should return here is something less. I mean, since it is returning finite models, basically people are going to want to get the models out and visualize the models and things like this. And what you're giving people here, and for example, what they might want to do is this might be a thing that searches for models, and people might want to just visualize, they might want to say, give me a bucket of 50 models that satisfy this set of axioms.
Right, but I think we could potentially follow the sort of proof object structure in doing that, we have this underlying association, but just as we can visualize the proof networks, there might be some nice way you could just, call into the counterexample object and say, visualize this as a multiplication table or something.
Yeah, fair enough. But that's with respect to counterexamples. What I'm saying is the positive case, namely, given this axiom system, just get me a bucket of 50 examples, not counterexamples, 50 possible models for that axiom system.
Right.
There may be a connection with find instance here. Exactly.
There might be, but the reason I'm concerned about that is that if you're finding models if you're trying to do a satisfiability problem, the fact that we've got universal quantifiers might be an issue. Because what does it even mean to say that if you're quantifying over all x, and x isn't even in a set here, this is just any object x. What does it mean to say that a particular model satisfies this axiom system?
Well, doesn't the model come equipped with an alphabet?
Yes. Okay. So yeah, in which case, we'd have to.
It's a finite model. So just like you give, I mean, what would happen is in your setup there, you'd be giving the alphabet as well as the multiplication tables.
Right. Yeah. So it would have a domain of discourse.
Right.
Plugged into it, right.
Which it needs to, because it's a finite model, and those multiplication tables are finite multiplication tables. So I think it needs that. And, what I would suggest is some kind of instance finding thing that where you can either give it the size of the model, or in fact, give it the elements that you want to use in the model, unless we just decide they're always, successive integers, which we might. You give it the size of the model, and it tells you what some examples right, there are two things you might want. You might either want examples or counterexamples, and you might not know whether the things would be. Yeah, right. So it either is the case that there are certain multiplication tables which are examples, or there are ones which are counterexamples in the sense that the axioms are simply not, the relations are simply not true. But I'm a little confused by something. Wait a minute. What is the deal? So a counterexample means that
in the counterexample, I suppose the primary difference is we have to specify, what the quantified variables actually are. Whereas if you're just giving a model that satisfies the axioms, you don't, because by definition it has to satisfy it for all.
Yes.
So the
complete alphabet. Yeah.
The structure would have to be slightly different, I think, between the counterexample and the satisfaction example.
Yes, but both are of interest. All right, this will take another separate design meeting.
Yeah.
Did you fix the examples for find equational proof to structure them better?
Not yet, but Jose and I were talking about it in our last meeting.
Okay. As soon as that's done.
One more comment I wanted to make here is that the thing we have seen users complaining about is that they expected the function to understand directly things like times and plus.
Right.
Capital times, capital plus. So the function to know automatically all the properties of these functions.
And
Interesting.
I think that the conclusion that we came to was that the best thing to do would be, if a user, or if someone puts in a statement involving say the plus operator, but doesn't give axioms which define it, then find equational proof should bring in some sensible
I agree.
like piano arithmetic or something.
Well, because effectively it's already doing that for the AND operation here.
Yes. Well, there is a subtlety to that, but yes, essentially, yeah.
Yeah, there is a subtlety now that I think about it, because like if those were axioms of Boolean algebra, it wouldn't have an AND in it already. I mean, that's some kind of meta level thing.
This AND is being converted into is making this a list of axioms internally.
Right. Even though it purports to be a logic operator there.
Yes. I mean, in the documentation, we explain that those two things are treated as equivalent.
Okay, I understand. So yeah, I agree with you that if you're using built-in system things like times and plus, that we should pull in axiom systems for those.
Yeah.
And I wonder what other, I mean, ultimately then, sort of the family of that stuff becomes, ultimately we could imagine a thing called group multiply or group times or some such other thing, which would have the axioms of group theory built in.
Right.
Yeah, that's probably the right way to do it. And many of those things would not have a, I mean, I don't know, in our group theory subsystem, Jose, do we have something which is a group times effectively?
Well, our group theoretical functionality is only dedicated to permutations, and we have a permutation product. And we have also a group multiplication table and things like that. But it's all oriented towards permutations. It can handle, say, permutation product of G and H, things like that. And then,
okay, so that's another example where, let's see, that's another example where we could have built-in, for the permutation product, then we could have built-in axiom system.
Right, correct.
Well, so what's the right, so I mean, are we going to use piano arithmetic or something for the built-in axiom system for times and plus? Some of that stuff is not purely equational, right? It's axiom schemas and things.
Right, yeah. That would require some work. There is, I mean, certainly you can use things like Presburger arithmetic. There are equational forms of that. I'd have to do some thinking.
But that's not strong enough.
No.
So an interesting question is, should we have an ability for find equational proof to call on our much more sophisticated theorem proving capabilities that make use of all of the fancy, algebraic structure of things in the case of plus and times, even though then some steps in the equational proof might be kind of oracle-like steps?
So we'd have steps in the proof that would, call out to full simplify or...
Yeah, for example. I mean, that's the only thing we're going to be able to do because we're not going to be able to represent. Well, this is something that dovetails with the whole lean Michael
correct
project. So that would be a great thing to. I'd love to know actually. Actually, I'd love to know sooner rather than later because it relates to a bunch of things that I'm thinking about. What we might be able to do with that. If you're able to find out from Michael, that would be great. I mean, even. I don't think we should take the time right now to do this. Well, unless somebody can find Michael. Maybe if you can find Michael, we could try asking the question at least. Eric, are you able to do that?
Well,
yeah.
We keep having meetings with Lean developers, and they have been working on a bidirectional connection now. So we had before a connection, so Lean calling Wolfram Language. Now we have also the beginning of the opposite direction.
Okay.
Mm-hmm.
Is there some report about that? I really like to see it because I'm thinking of writing this blog post about the logic stuff, and I would like to see that in connection with that.
James may be able to show something. Yes.
Okay. If somebody could ask him to send that, preferably by the end of the day, that would be great.
Mm-hmm. Okay.
Okay.
Is that James Molnett?
Yeah.
Okay.
Yep. All right. I think this is probably everything for this, and we'll have to leave this as
Okay.
experimental. But okay.
Okay.
And Jonathan, you're coming to the summer school. Is that true?
Yes, I think so.
Good. Good. Okay, I'll see you there. If all right. Anything else for this for the theorem proving stuff?
No.
Okay. Let's move on. So Jonathan and Jose, I think your part is done here.
Okay.
Thanks.
Then we leave. Bye.
All right. See you later.
Bye.
Bye. Okay, we have Sebastian from MongoLink.
Yes.
Okay, what's the deal here?
So
I mean, this is all in
should
its own
be-
context, and I'm not quite sure what the Go ahead. What were you going to say?
Yes, so it's basically only been there since 11.3. And so I basically said that nothing should be de-experimentalized. And there's some things already we've realized we've had the wrong design.
Why is this not showing up? But why does Mongo not show up as a why is that? By the way, you have a bunch of background noise, Sebastian.
Oh dear.
I don't know why this says MongoLink operations. Why isn't this just MongoLink? And why doesn't this get tagged as experimental on this page? This should be tagged as experimental. All right, this is not ready for prime time. I mean, this is how. But Sebastian, tell me about how it's being used so far.
By external users or for internal users?
Anything. What's the experience with it so far?
So far, the main issue that we've had is exposing. So it's a similar thing with having connections to other kinds of systems where they have vast numbers of options. And sometimes you really want those options, but it's quite annoying to have to make them into mathematical options. And also there's often new options that come out and then you don't know which ones you're not supporting.
Cut to the chase. What we've been using this for a bunch of machine learning data storage, yes?
Exactly, yes.
And
we're also using it for training. So you have the Mongo server on your local machine, and you can basically random sample from a massive data set that's out of core.
Okay.
And that's documented in your networks.
Okay. But I mean, so are we trying to make this be a more consumerized thing for our users as a giant key value store and so on?
So basically, this interface is probably going to stay in a very similar form to what other interfaces to Mongo look like.
Yeah, I understand. I'm asking the question, are we intending to build a higher level thing? And if so, what is that higher level thing? I would assume it's essentially a key value store. Is that
sure? Exactly. It's just a key value store, precisely.
Okay.
But a key value store that has,
that can potentially have a petabyte of data in it or something.
Yes, and it has efficient aggregation pipelines and whatnot.
What does that mean?
So it can do things like random sampling. It can do all sorts of transformations of the data before it comes back to your machine.
What kind of transformations?
Okay, so the simplest transformation would be to, let's say, drop. So it's basically a data set, like a mathematical data set. So it's a list of associations.
What is each data element or the whole thing?
So the abstraction is that you have a collection, which is just basically a list of associations. And it becomes a key value store because the association has to have a unique key called ID. Yeah. But otherwise, it's basically just a data set.
Okay, but it's a simplified data set, which happens to be a list of an association.
Exactly.
Right. So is it the case that we could imagine having that be a backing for an out-of-core data set of that structure?
Precisely, yes. So it does come with limitations. So things like every association can only be 16 megabytes, for example. So there's certain annoying things like this.
Well, what the hell is that? I thought the thing could deal with giant. I mean, so those associations are essentially the metadata of some giant thing. Is that right?
The association is, that is the data. So
no, it's not. It's a petabyte of data. It's stored as links from that association, right?
Well, no, it's not. So one way of storing a petabyte of data is that each association is, let's say, 10 megabytes, and you just got lots of them.
I thought they were in a list. They don't have keys.
They have a unique key called ID.
But
there's
is
a
that
list of those.
A sequential integer, or is that something different?
It's usually automatically generated. You can give it just sequential keys if you want, but yeah, if it's automatically generated, it's like a timestamp, like to the millisecond or something when it was created.
Okay, so again, so you're saying this outside list can be of any length, is that correct?
That's correct.
Okay, but each individual association is only 16 megabytes.
Correct.
Okay.
So there is a mechanism for representing files. So if you have, let's say, a bit like video, so this is a common application of this sort of database, is that it's one of the things that it does very well is that if it can distribute itself across multiple machines in different geographical locations.
Yeah.
And you can use it as a content delivery mechanism. And the way that works then is that you split the file into multiple associations. And then, there's an API for putting it back together again. Okay.
What is the top level? It's so frustrating to have this background noise and talking to you that I'm
sorry, I'm not sure what this noise is. It's very quiet.
Well, I think it must then be electronic noise of some kind. It's like we're hearing another conversation.
Oh, I see. Okay. Just give me a second. I can get rid of that.
Okay.
Sorry, back.
That is better. Okay. So again, it's not perfect, but okay. Now we're moving around. But okay, never mind. I'm trying to understand the top level thing here. What would it look like? What is the thing that we can provide to users based on data set, out of core data set, anything else that would make use of this functionality?
Sure. So one of the things would be data drop. Like that's a very natural fit for this. So at the moment, data drop is based on I think it's backed by files.
Yeah, it's backed by files.
Exactly. And that has all kinds of performance.
Yeah, okay. So how would you use this for data drop? You just use that big, long, to the millisecond time-stamped list as the successive elements in the data drop. Is that correct?
Sure, exactly. And then it's a time-ordered sequence, which is what you want.
Has anybody ever talked to anybody about this? It's the first I heard about this being used for data drop.
So I've had conversations with the data drop people, and basically they just don't have time at the moment to re-architect the system. But they definitely want to, if there is time for it, they want to re-architect it using a database.
No. I've heard that silly story before. The arguments for that were extremely unconvincing. Maybe they're more convincing here, but is the ultimate data stored inside Mongo, not in a 16 megabyte association? It isn't. It's got to be stored in a file ultimately as well, if it's a big thing.
No, so it can live perfectly well in Mongo. So there's this abstraction called GridFS, Grid File System. So it does split things up in the backend into 16 megabyte chunks, but there's an interface that I haven't exposed yet in MongoLink that basically makes it look like it's just a normal file, and it lives perfectly well in the database.
Okay. Well, this will be really worthwhile to have a conversation about data drop and this, but it's not for this meeting, and that should be separately scheduled. But I think for what we're doing here, the basic bottom line is great, stays experimental, continues to gradually progress.
Exactly.
Are we putting, I mean, the whole MongoLink code base, is that something that we've like put out in, GitHub or something? Or is that, what are we doing with it?
There's a process to migrate it to GitHub. Okay. So it's not on GitHub yet, but it will be there quite soon.
Okay. By the way, one thing we should be aware of, and this is for Raj, I guess, when we have done these things of putting some of the code bases on, out in open repositories like GitHub or our own open repository, we should indicate that somehow on the documentation pages as a C also or something like that.
Okay.
Can you communicate that to Brian van Vertlu?
Right. That I'll make sure it's in the next doc design meeting.
Sounds good. All right. I think that's it then. Anything else?
Nope.
Okay, great. For people on this live stream, we haven't had a lot of activity that I've seen here, but we'll actually be coming back in about 15 minutes for another episode in machine learning. So until then, see you later. See you later, Raj, Sebastian, etc.
Yep.
Bye.
Bye.
Bye.